Okay, let's talk about table titles for a minute. Table titles are a hard one. It's very difficult to make a good table title because you need to keep it short. The worst thing you can do is keep it long. So let's look at an example here. Table 1, here's an example. Relation between college majors and performance. It is unclear where data is presented in the table. Okay, so this is a little note here. Let me separate this for you. This is just read there. Relation between college majors and performance. Now that seems to be kind of brief, but it also seems to be very general. So it doesn't tell us what the research really is. Here's one that's a little bit too detailed. Mean performance scores on test A, test B, test C of students with psychology, physics, English, engineering majors. Ooh, there's a lot of majors. That's what they're doing. And just read it over to here. That's a note after that. So one is too short and one is too long. The too short one is too general. It's just saying, well, I studied college majors, but this one here, it's got all the majors listed. That's too much. This one here talks about a relation, but this one down here actually tells you relation of scores between test A, test B, test C. So these are two extreme examples. A good compromise would be in the middle, something like this. Mean performance scores of students with different college majors. So we do mention majors, but we don't say what the majors are. We do say that it's measuring the mean and the performance scores of the subjects who are students. So this is a good title for a table because this table is going to show me the students. The variables are going to be the performance scores. The numbers inside of here are going to be the means, and the subgroups are going to be the college majors, the small n, right? Okay, it's really hard to make a good title, I have to admit, but usually a rule of thumb is when you format your table and then you write your title, if you're going to go all the way over the margin and return to a second line, you're probably starting to get really long. So how many words is that? 7 to 10 words. You really need to fit everything in there to make it clear. Abbreviations in tables can be explained in the table title. So if you have an abbreviation in your table, for example here, FA, hit and false alarm proportions in experiment 2. This is a title of a table, and inside the table we have FA. What is FA? Well, we go ahead and we explain it inside of the title. Now we could do it in a note. Why would we not put this inside of a note at the bottom? That's perfectly acceptable. In fact, inside the table we could have FA and then put a little asterisk, and then down in the note we could say, what does asterisk mean? That means FA, false alarm. Why don't we do that? Well, you could do that, but in the title we put it in there because we're saying this FA is really key to understanding this table. This table is about FA. If you go read the table and you don't know what FA is, that's really confusing. So you can go ahead and explain the abbreviation inside the title. You can abbreviate non-technical terms. So for example, you could say NO for number, NO period. You could say percent sign for percent. For statistics, you could write M, you could write SD, standard deviation, you could write chi-squared. So you can use these ways to try to make your table title a little bit shorter. What about table headings? So here we have some headings for these columns. So on the left side here is the grade level, and then on the right side is grade. Which one is a better heading for that column? Grade level, the problem is it's getting very long. Grade is much shorter. Now, is it unclear? Is it unclear? It's a little bit unclear because it's like, what do you mean grade? You mean like grade, like the grade you get in the class? So you need to watch out for that, and you could have a note at the bottom. Grade is the grade level 1 through 4. Grades 1 through 4, something like this. One thing is for sure, if you make your table headings long, you're going to run out of space on the page because you need to fit everything within the width, and that becomes very difficult. So let's look at another example. Here we go. here we're going to look at stubs, and this graphic's getting a little bit tiny. You might want to enlarge it on your screen if you can. And in this case, we have these stubs on the side here. So over here, down here, and down here. And here we have a very good example of how we're getting into the detail. Experiment 4A, experiment 4B, experiment 5. And then this is stage 1, stage 2, and the test that's being performed. So in this case, we can see an example of how to make our stubs a little bit easier to understand. And one way to do that is to use indentations. So here we have experiment 1, block, unblock, unblock, experiment 2, experiment 3, experiment 4. Here we're indenting a little bit. You see that? Right there. And that makes it easier for us to see the subgroups. So this is experiment 1, but then we have experiment 1 block, unblock, and then unblock number. So it's a little bit indentation can help the stub to be easier to understand. Also over on this side here, for this example on the right side, you can see that we have a lot of notes down here. And these notes are explaining a lot about the table. This note looks really long, doesn't it? A long note. What's wrong with a long note? Well, there's nothing wrong with a long note. Actually, it's very common to see really long notes in very technical papers. Why is that? Because you're basically saving a lot of space in your paper by putting everything into the note. You don't want to explain all of this inside the body of your thesis or inside the body of your research paper, because it's going to make it really long, and the person reading it is like, this is way too boring, doesn't really affect anything, but it is key to understand how you came to the numbers you got. So you put it into a note. It's a perfect solution. And this is an example of a really long note, but I would not call this too long. One thing that this note is doing is you can see down in here like M-E-I-M, and here is M-E-I-M, right? And B-D-I, and here is B-D-I. So what's this doing? Well, B-D-I is block depression inventory. Back depression inventory, is it? And M-E-I-M is multi-group ethnic identity measure. Multi-group ethnic identity measure. Whoa, these are really some long phrases. So those are way too many words to put inside of a table, to put inside the stub. Remember, the stub has got to be short enough, and then you've got to have your numbers. So in this example, a really good example of use abbreviation, that's A-okay, but then you go ahead and explain it in your note. Let's look at table headers and spanners. So here we have this idea of the one column, one head, very straightforward. So here we have this example here. This is a column, and that's stage 1. This is a column, that's stage 2. That is really straightforward and easy to understand. 2 or more columns together, that's going to be a spanner. And in this case, we can see that over here, in that if you look here, we have 2 columns, don't we? And then here another 2 columns, and here another 2 columns. Because those 2 columns are different information. In this case, the information is the mean, I think, and then the standard deviation. Decked is a little bit more complicated, and decked means that we put them together in a way that makes it save space and easy to understand. So if we had this idea of temporal lobe, which is a part of the brain, right? The left part of your brain, the right part of your brain. So if we're doing some kind of testing or some kind of experiment, and we're looking at this temporal lobe, left and right, we could write it this way, or we could go ahead and say, left temporal lobe, what are the results? Right temporal lobe, what are the results? But the easiest way to do it is this decked way, which is I'm looking at the brain, and it has 2 parts. And so now I'm going to give you the data for the left part, and here I'm going to give you the data for the right part. And that's called a decked table head. Extremely useful for saving space. Here is an example of the deck at the top. So we have mood, and then before and after moods. So this is before some kind of activity. I think it's some kind of exercise. This is after exercise. So I'm looking at the mood before and the mood after. That's a very clear and easy way to use it, decked. What about capitalization inside the table? Well, inside the table, you're going to be capitalizing the first letter of the first word for the column headings, for the column spanners, for the stubs, for the heads, for the table spanners. So basically, all the parts of your table inside, you're just capitalizing the first letter of the first word. So what about the table body? Well, inside the table body, you can use decimal places depending on the statistical power. So this is something people often forget, and that is how many decimal points should I have? So if I have a number, for example, that's 0.00000001, how many decimal points do I use there? And the answer is quite simple. It depends on your statistical power. And the easy answer is try not to use too many, because if your sample size is not very large and you don't have very much statistical power, when you write 1.11258, you're writing way more than your statistical power can actually analyze, can actually see. So try to keep it as short, as few decimal places as possible, and often 2 decimal places, 0.12, is probably all the power you've got. And if you have a small sample size of, say, 20, 60, or 100 people, you probably don't even have that much statistical power, and you're probably down to 1 decimal point. So please pay attention to that, because that's often a sign of amateur statistical analysis. Now, can you have empty spaces or empty cells inside your table? Well, yes, you can have empty spaces, but there's a special case. An empty space means that there's actually nothing that goes there because there's no measurement there. In other words, it's empty because there is no reason, there's nothing there. Like you didn't, it's just, that doesn't belong there. That would be empty. But that's not normal, is it? Usually what we have is a space where we should have data, but somehow we didn't collect any data. A very good example of this would be you have many kind of subgroups, and you have many different variables. And of course, there's a chance that some people did not answer some questions, or some people did not perform some test, or did not react in some way. In that case, that's not an empty cell. That's a cell where you should have data, but for some reason there is no data. And maybe because nobody did it, nobody answered that question, nobody performed that activity. But that cell is not empty, it's just lacking data, missing data basically. So if you're missing data, then you do not leave it empty. Rather, you go ahead and you use a dash inside that cell, and that symbolizes the data is missing. Save space by not reporting what can be calculated. So if there are numbers that can be calculated by the user, by the reader, you do not need to also report those. For example, totals and sums and subtotals. Don't add all those things if people can just take a calculator and do it themselves.